Welcome, guys. Um, Tonight I'll be trying to add the symbol table into the assembler. I want to add a symbol table. I want to get everything working on that end so I can actually finally get to the good part where we start writing the object code. And we'll get started. So basically what I need to do is, I think it says I need to add a special case to pass act to see in special case for if you put a label by itself on a line or a totally blank line. So basically that's what I need to do. I think I removed all the blank lines, so that's okay. Void pass act. Let's see. Let's see where they put this little special thing. Pass act. If label's not equal? Okay. What is going on? Cool. That's strange. Let's look. So if op.empty so that's actually in process. That's actually not in pass act. OP if so instead of return, actually I need to do pass act pass 0 -1. That sounds about right. Okay. Process function. I'm stupid. I'm stupid. We gotta read the actual manual, folks. That is a retard alert moment. Not gonna lie. Okay. What does the addition of this line of code do? Mnemonic. So symbol tables need to have data structure, right? The data structure we'll hold on to is a struct containing a string and a use short, but that only handles the individual label, and just pair will have many labels. So a single struct alone will not be sufficient. There are a couple of different data structures. If we were going to be writing the next production quality assembler, we might have chosen hash table since it allows really fast lookup, Pet over Pascal, virtually solve the simply linked list. But we're not going to do that. We're just going to do an array of structs. You're allowed to make arrays of structs. So basically, this is what I'm going to do. I'm going to go up here. I can delete this, y'all. Okay. Symbol table struct. Okay. Howdy. Good evening, folks. If you're just joining me, we are just now we're working on adding the symbol table in. So we'll see how it goes. So let's do a type def struct. Let's say symtab. And I will say string label. Actually, it'll be what? Char label. I don't know. 16, right? We'll do 16. And short uint 16t value. Cool. Then make an array. So let's do up here symbol table allocated size. Fine. Symtab size. Let's just do 128 for right now. Definitely that should be something that can be changed. And what you can do is you can do an if and def. So basically I can do like if and def symtab size, and then I can do that. So basically if I want to change the symtab size on the command line, I can do so, and if I don't have it, it will be there on compile. Generally, that's how that works. I really like that C compiler does that, but I don't know about the Aztec C compiler. So now we need to malloc a bunch of memory. Right. Allocate an array of line structs. You can do that. So basically, let's do that here. I've done this before. I just can't remember off the top of my head. Okay. So symtab equals malloc. I think you need to function call is not allowed in constant expression. Here. So let's do a global there. I don't even know what's going on here. Cool. So symtab is malloc. Mosquito bites, man. So many mosquitoes here. So They call it stab. I'm just trying to keep names the same so I don't completely lose my way. And if I need to, I could do a realloc, but that's I don't want to deal with that right now. Let's add a function called add sim. So if we go up here to add sim, and this, I'm just like assuming this will work. Dog, I'm not doing anything here. So where is add sim? Add sim is here. Let's pass in pass size right. And let's look. Is outbyte assemble? I gotta deal with this. The out file. I gotta deal with that process. Int outbyte use short size u and 16t. I'm doing that just to be sure things are right. So what? Let's see. And I for size. What is for size? Sorry, size ti for I equals 0, I less than so basically what's going to happen is every time you add a symbol, you're going to see if it's in there. So check to see if the symbol already exists. Okay. Otherwise, add it in. So where's that malloc? We will do calloc so if stab dot 0 or stab size arithmetic arrow pointer type doing here? What am I doing wrong? If the address, because these addresses should be null, right? So break if showing dot lib equals style dot lib. So comp because remember we're doing this all in C. Okay. Yeah, we're doing this all in C, so we're not doing D. So if it equals, then press duplicate, no, we'll do printf duplicate label. Look at that. Parsed label. Cool. Never give up, bro. Thank you so much. I'm sorry if I just saw that. I don't have a good place to dock these windows. I'm using my drawing tablet as a second screen, so that's always fun, right? Anyway, let's continue. So after all this garbage, after the for loop, what we're going to do is we're going to add it. We're going to add, so add symbol to the table. So basically what they're having me do is they're having me make a struct and then stick it onto the array. But I think I can do you, well, goddamn. I'm thinking. Basically, I need to find the end of the symbol table. Hang on. This breaks out when I reach the end, so I actually has the last location. Cool. So I would say stab I dot lib equals parsed line dot label. What's going on? Cool. So I'm copying it over there. And then address. So this would be stab I dot value equals address. Cool. I think that's how you do it. Of course, this is all, I'm just winging it here. I'm completely winging it here because you can't really debug this halfway through. Now we are processing the no-op instruction. So if we go to the no-op instruction, I don't care about argcheck. Argcheck is, I do not care about argcheck right now. I'll add that in later. So basically, now what I have to do is I now have to do the output. So if we go down to assemble, and go here, wait a minute, how do I do this? After all the code is emitted, write to the output file. So assemble, pass, file write. And file write is just write the output to the file. So then if I go up here, go all the way up here, void file write, write byte array to file in C. Dog, there ain't no byte array like that. So let's do f byte. Output size of byte, size of output bin f pointer. And then if you go to fclose, let's look at this file. Let's try it. It built. Let's try running it. Oh boy. Let's look. Passing argument 4 of fwrite makes pointer from integer without a cast. Pointer from integer? Oh, right. Because I think when you do this, it is implicitly a, we're going to do a retard moment for this one. When you do I need like an actual like triangle here, bro. When you do a implicit variable pass, it is by default an int. So I need to do file pointer. There, now let's try building it. There. Now it works, folks. Now it works. Well, it compiles. Just because it compiles doesn't mean it works, right? Let's try this. I'm going to try it, folks. I'm going to try a80.exe no op.asm. No mnemonic, no op. Well, that isn't promising, folks. Oh, God. Hang on. I just made retard alert. I just made a 32 kilobyte size file. I gotcha. If I look at output counter, if I go to fwrite size of byte into output counter, then it should only write the number of bytes that are actually written. Why is it unknown mnemonic? So let's see. Unknown mnemonic. If so, start to lower parsed op. Let's do a put us parsed line dot op right there. Put us raw op. My ops dog build. Let's comment out this garbage too. Where is it? Let's comment this garbage out. Cool. Then I go here and delete this. So it says that, so should I, let's there's so many things I'm trying to do. Basically, let's look at output counter. Let's see where it's incremented. Let's not do it there. Where is no op called? No. No, let's do this. That's correct. That's correct. Let's keep it that way. Let's keep output counter there, because who knows? Maybe it's multiple bytes, right? Maybe it says multiple bytes that I have to write in. But why is it not? Do I have to like? Trim white space first line dot up. There's no way, right? Oh, no mnemonic, no op. What's going on? Let's see. What's going on? Compares two strings S1 and S2. The locale is not given in the context. Always returns an integer indicating result 0 if. Oh, what? Am I just retarded? I'm just retard alert. Read the goddamn man page, folks. Actually know what your functions do. Oh my god. Okay. So do I need to do that? Yeah, I do need to do that. Let's try this now. What's going on here? What is going on here? Let's see if it's the no-op function that's breaking everything. What is put s doing? Cool. Right here. No op and no op. Is breaking it. Okay. Pass act. Let's try this. My god, you'd think I like pass one of process func process done. There. Let's do that. That's my official debug line, folks. So then if I go to pass act, it breaks. So if I go to pass act, if pass equals 1, so then basically go to pass act. If pass equals 1, okay, if pass line label is not empty, no, there. I totally get completely turned around. There we go. I completely get turned around on my dereferencing and stuff. It's so annoying. Still nothing is being written out. Okay. Still nothing is being written out. Pass act. I didn't expect this to work full time. Like I didn't expect this to work the first time. Yo, Bunny on the back. Yeah, I'm just working on the 8080 assembler in C. Again, this is I've never written assembler before, and I think I'm good at C, but I'm really not. Like I'm not amazing at it, you know. Even though it's been my day job for the last 8 years, like I've made cool stuff in it, but nothing like. Dude, I do OpenGL in C. I have like in C I have done raw OpenGL and made things run at like 218 FPS on the Raspberry Pi Zero in C with OpenGL using shaders. But a simple assembler, it blows my mind. It's annoying, but you know, you get used to it. Anyway, yeah, this is a desktop, you know, Windows 10 running a 8080 assembler. Now, of course, I know you can get yourself a Z80 assembler and it's all the same stuff and blah, 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 but I want to make it ourselves because you know why? Because when we make our own assembler, we can then continue with this tutorial series and make a compiler. That's right, I want to make a compiler that will compile a custom language down to 8080 assembly. So many languages do, like, you know, the Z80 or something like that, but no, I want the 8080. I think the 8080 is a much underrepresented chip in the hobbyist computer space, even though it's just a really terrible Z80. I digress. Anyway, we're going to see if we hit the pass act function. Nice. Learning JavaScript. Funny enough, we had a cool pass act is. Wait, what? We'll deal with that in a second. Yeah, funny enough, actually at work today, we had a whole meeting, like about an hour, of how we were switching from C# to a JavaScript framework. Basically, it's still C#. The guy basically wrote a JavaScript interpreter in C# for us to use, so all of us can use the same code instead of literally every single one of us doing something different. So that'll save so much time. Anyway, pass act. So no-op pass. And here's where I pass act should be tripped twice, should it not? Let's try this. Let's try this. Okay. No, I don't know what I'm talking about. I don't know what I'm talking about, folks. I'm retard alert. It's getting late, folks. Oh my god, I gotta stay locked in, dog. Pass act. Why is this not happening? Let's see if pass 2 is being hit. Because that's where the output is being written. This is not being hit. Pass act is not being hit. Why is pass act not being hit? Why is Gavrilo principle an 8080 assembler is basically a program that takes your assembly code and converts it from the assembly code to the actual machine code for whatever processor you're targeting. And I'm targeting the 8080 Intel 8080. The Intel 8080 was this chip. It was an old chip from, what is this from? 1974. And this chip is inside so many retro computers. There's only 4,000, 4.5K transistors, or something like that, right? And this thing ran CPM. It ran so many other pieces of code that are, well, infamous, really. If you've watched War Games, that old movie, which I still haven't watched, but that is an IMSAI computer, and that ran in 8080 originally, and it might have been upgraded to a Z80, but basically this is the instruction. This is the architecture. There's 8 registers in the entire thing. Each one's only 8 bits wide. And yeah, it's a very simple processor. And I love it. Altair 8800. Basically, this computer, the Altair 8800, ran this. And there's only switches on the front. There's no keyboard or anything, at least by default. Now you could add a keyboard to it, but you had to build that yourself and write your own code to use the keyboard and that sort of thing. I have an emulator for this sort of thing. I don't have the real thing because a working Altair on eBay is tens of thousands of dollars, and I got a working clone for like emulator for like a couple hundred on Tindy. So yeah. And this chip is what got me into retro computing, and I absolutely love it. But I've never written my own assembler for it. I've written a terminal for it, for the computer. I've written some games for it, like a maze generator and stuff. In fact, on my YouTube channel you can find those. But I've never written an assembler for it. To write assembly code, which looks like this, turns it into machine code for the computer. I love assembly. On my channel I have tons of assembly tutorials on how to do special things in 8080 assembly. Anyway, I hope that answered your question, if you didn't click off, because it's very long-winded and boring. Anyway, let's go up to the parse function. nothing's happening on pass 2 of the parse, which is fine. Nothing should be happening on pass 2 of the parse, if I think. I go to his D code. Yeah. Well, what is going on? What? Hang on. I'm losing my bananas here again. Go to assemble. I'll call assemble. So what this does is this process, parse, assemble. My code is wrong, I think. No, it's not. For each line, process. That should be fine. Then what the hell is wrong? So we're going to process. Hang on. Let's look deeper. I think this code right here is actually, what's the problem? This actually shouldn't be there because process is being called twice. Well, I have two, do I have two? Hang on. No op. Instead of, let's do, what's A? What's A in hex? Let's go here, programmer, hex. Let's try running this again. My God. By the way, what the hell am I listening to? So I have two no ops. I have two zeros in there, which I'm not sure is right. It should be this, right? It should be this number. Hang on. I don't care that it's two zeros. It should. Hang on. Let's look at this. So first is pass act. Okay, let's start from the top here. Let's start from the top here, folks. Pass one of function process done. Basically, what has happened now is when you do the first process, okay, that makes sense. No. Pass act is called first. Let's try this. I'm going to comment out that first pass act because maybe the second one that's in the no-op actually triggers. Okay, correct. This one actually triggers. So if we go here to no-op, pass act, you hit pass act, and you don't hit this. And you hit. Okay, so it's working. That is working. We're so close. We're so goddamn close. We're so close. I think the flow actually works correctly. Okay, so then why is it not writing what I want? Okay, let's go to no-op. Let's hit no-op. Right. Let's see about this. Hit no-op, hit no-op. Okay, so let's go into pass act. Into outbyte. Do I want... What is this? What is this? What is if outbyte is greater than 0? Oh, greater than equal to. There we go. And then output starts at 0. Okay. I know I'm like sort of making a bunch of like do you see that? Do you motherfucking see that shit? Do you see that shit? I'm gonna zoom it in for all y'all in the Do you see that? We have, yes, we have a success. Basically, all I've done is I have one instruction. I have one instruction in my source code, the no-op. And of course, the no-op isn't supposed to be, 65. It's supposed to be 0. But I just put 65 in there, which is E in ASCII, just so I can see it. And it's there. Now, of course, if we look here at the actual object code. It's actually 0 and then 65. So screw you. Let's try this. Let's try 2 no-ops. 2. We're gonna try 2 no-ops. Look at that. I still don't know. I have no clue what the hell these leading zeros are. That's really weird. Okay, let's work on this. Let's work on this. Why is that? Why is that? If I do 3, what if I like delete it and then try running this again? What? Wait, what? What? Hang on, folks. What's going on? What's going on? What the hell? Literally, what the hell's going on? It's only working if I have a 1, 2, 4. What about no up here? Will this work? One, 2, 3, 4, 5. Why the hell isn't it working with 3? What sorcery is this? And I don't have a new line here. I'm at a loss. Something's going on. Something absolutely wild is going on here. I'm sorry. I'm taking a bug bite as we speak. I think this is a good stopping point. We have an assembler. It assembles horribly. It sends the wrong object code, and it assembles it only if you have like a certain amount of opcodes in your source file and a new line or no new line. So who knows what's going on there? But I think this is a good stopping point. And once we get this bug fixed, these couple bugs fixed, we can then just add the rest of the opcodes. And as far as I can tell, we have an assembler. Now, of course, we'd have to, we have the simple table, but we have to implement the symbol table so we can do forward referencing and stuff, because that's what a 2-pass assembler does, is it first build the symbol table and then allows it to do forward referencing. And what is forward referencing? Forward referencing is basically, here, I'll show you. So here in test ASM, as you can see, I want to basically I'm going to move 1 to the accumulator, 1 to the B register, and then add B to the accumulator and store the accumulator to ANS and the answer, right? And answer is a label that is down here. We haven't seen it yet. We haven't run into the ANS label yet. If we did this and we did something like this, then maybe that would work, right? That would work. 0 is just a no op, so we would just run right over that. because ANS has already been seen, that isn't a forward reference. So a one-pass assembler would work in this case. One-pass assemblers are technically simpler, but they're much harder to program for. They're not impossible. They're just much harder to program for, and really they were meant for paper tape machines where it was just such a pain to run the paper tape assembler through and then take it all out and run your source code and then run the paper tape assembler again through, and yeah, it was just a nightmare back in the day for that sort of thing. That's why two-pass assembler was two-pass assembler was made once paper tape was no longer the main default. This is for disk drives and stuff like that. Okay. I know someone just joined in, but I'm sorry. I'm actually gonna head out. Thank you for joining in. Anyway, of course, this has been fun, and yeah, we basically have a halfway working assembler on one opcode, which sounds like not a crazy accomplishment, but it is a huge accomplishment for me. And once we get these bugs ironed out, we can then finish the rest of the opcodes, implement the symbol table, and assemble their code on a Windows 10 computer. Okay, guys. Hope I'll see you in the next one, and good night.